Okay, in this video, we're going to talk about the differences between lexical scope and closure. Now, a lot of people think lexical scope is closure, but it's not. Closure only happens after you call a function, and I'll go into that. So what is lexical scope? Lexical scope in JavaScript means, hey, if there is a variable on the outer scope, anything that's on the inner scope, let's say on line 10, this console.log, it's inside of the function run scope, which is the inner scope. So inner has access to outer. So when I do console.log, it says 5. Now, lexical scope also says if there is the same variable inside its own inner scope, then it will stop looking for that variable, right? Here it finds num equals 1000 in its inner scope, so it takes that. If it cannot find it, then it goes to the outside. Cool. But now, what about closure? How was that different than closure? Well, closure works like this. Let's say if I have const secret name, fill up, and then let's do const secret password, 1, 2, 3, 4, 5. Now, what if in my function run, I just return an object that has the names and values of these two variables? Well, okay. So now when I run this function and this return statement runs, we just used closure. So what does that mean? When we have this return statement, we're now saying that, hey, our function run is closing over the variables of its own scope, secret password and secret name. But it's also closing over all the variables of its outer scopes, including new. Okay. So now, even if we don't run this right away, let's put this const ARR is equal to an array, right? And then let's do ARR.push, and then we're going to push in the result of run. Okay. So on the right, if I do ARR, you see that it has everything that we need. So if we do ARR at 0 dot secret password 1, 2, 3, 4, 5, let's change this to 0. Okay. So now if we do ARR at 0, we see that the secret password is 0. But if we do run, you see that the secret password is still 1, 2, 3, 4, 5. Okay. So using closure prevents the user from changing the original formula. Okay. They can only change the instance, such as right here. Okay. So what's another way we can use closure? Another way is that, hey, we don't have to expose all the variables that we don't want. So let's say I have const my boss is equal to, let's say, Joe. Okay. So now on the right, if we click run, we don't get access to Joe. We only get access to whatever that user or admin wants us to get access to. So this is why closure in conjunction with lexical scope is very important. Now, here's the most important part I want to talk about. What if I also return the global new? So on the right, when I do run dot new, I get 5. Okay. What if I do something like this? Function run2. What it's going to do is it's going to declare another num, const num is equal to 10,000. And then it's going to return the function call of run1. So now what do you think num is going to say? Is it going to say 5 or is it going to say 10,000? Okay, so on the right, let's do run2.num. Why is it saying 5 and not 10,000? Okay, this is how closure works. When you call run2, it declares a variable num is 10,000. Then it returns a function called run1. When run1 runs and it gets to this part, it says, okay, my closure is saying I need to access a variable named num. So there's two. There's one here and there's one here. But closure says originally the num that I was referencing lives on the global scope. Okay. So then it compares, hey, this guy is living somewhere else. It's not living in the same scope as the original. So I'm going to take the original value. This is how we get 5. But if instead we're not assigning a new num, but we're just reassigning the old num, now we're going to get 10,000. Because when this closure runs, again, it says, okay, the num variable must be named num and it must live in the global, which this does. But now, since there's a new value and it's updated, Clojure will automatically update that value for you. Okay, how cool is that? Now, what happens if we